hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at LearnoHub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 7, Ratio and Proportion, topic Proportion. We'll understand the concept with examples and solve more questions from exercise 7b. Are you all ready? Let's solve together. First, let us understand the concept of proportion. Here I have taken 4 rectangles. This is our first rectangle, second, third and fourth. Okay, this is a rectangle's length and this is its breadth. Here for the first rectangle, I am taking the length as 5 cm and breadth as 3 cm. For the second rectangle, the length is 10 cm and the breadth is 6 cm. For the third rectangle, the length is 15 cm and the breadth is 9 cm. For fourth rectangle, length is 25 cm and breadth is 15 cm. Here, using this rectangle's length and breadth, we are going to understand the idea about proportion. When you take the first rectangle, what is the ratio of length and breadth? We have studied ratio in our previous classes. Okay. So, length by breadth is equal to 5 divided by 3. Okay. Ratio is expressed like this, 5:3. Now, when I take the second rectangle, for the second rectangle, length by breadth, the ratio of length and breadth is equal to 10/6. Okay, that is 10:6. This is how we express the ratios. Now, when it comes to the third rectangle, length by breadth is equal to, length is 15 and breadth is 9. 15 divided by 9. Ratio is 15:9. Now, the fourth rectangle, length by breadth is equal to 25/15. 25:15 is a ratio. Okay, now we are going to compare them. When we take the second rectangle, length by breadth is 10/6. This can be simplified, right? 2 into 5 is 10. 2 into 3 is 6. This is equal to 5/3. Simplified ratio is 5:3. Now, when you take the third rectangle, here we have 15 and 9. 15 is 5 into 3. 9 is 3 into 3. 3 and 3 cancelled. We will be having 5/3. Here again the ratio is 5:3. The simplified ratio is 5:3. Now, the fourth rectangle, 25 is 5 into 5 and 15 is 5 into 3. This is again 5:3. So, when you compared the length and breadth of all these 4 rectangles, we got the ratio 5:3. That is, the ratio of length and breadth of the first rectangle is equal to ratio of length and breadth of the second rectangle is equal to the ratio of length and breadth of third rectangle, which is equal to the length and breadth of the fourth rectangle. Okay. Therefore, proportion is actually a comparison. This comparison is what proportion is. Proportion is the comparison of 2 ratios. When you compare these 2 rectangles or these 2 rectangles, here in every cases we are making a comparison between the length and breadth. We got the ratios equal. Okay. So, proportion is the comparison of 2 ratios. Now, here we have some values. If in case we don't have any values, that is, for non-zero quantities, A, B, C and D. We are taking some non-zero quantities A, B, C and D. In that case, the proportion can be expressed as A is to B is equal to C is to D. Here, this is A, this is B. Okay, this is C and this is D. For example, we are taking these two rectangles, first and second rectangles. In that case, A by B is 5 by 3, C by D is 10 by 6. That is again 5 by 3. This is how we can compare. Okay. Now, this can also be expressed as A by B is equal to C by D. Okay. The general notation is A is to B as C is to D. So, this equal to is replaced with a sign that is to, 2 times is to, which is called as. This is A is to B as C is to D. Got it? In our daily experiences, for example, we are making a tea. For 2 people, we are making tea with 1 glass of milk and 1 glass of water. When the number of people increases, what we do? We increase the quantity of milk and quantity of water in equal amounts. We take 2 glass of milk and 2 glass of water. This is again a proportion for 2 people and 4 people. We are taking 2 different cases. Okay. First case, 1 glass of milk and 1 glass of water. In second case, 2 glass of milk and 2 glass of water. Got it? This is again an idea about proportion. Okay. Now, there are some important points that you need to remember. We have A is to B as C is to D, or A is to B is equal to C is to D. This A, B, C and D are called terms. Okay. A, B, C and D are called terms. The first term, A, is the first term. B is the second term. C is the third term. And D is the fourth term. Okay. A, B, C and D are called terms. A is first term, B is second term, C is the third term and D is the fourth term. Now, A and D, the terms which comes at both the ends, they are called end terms or extremes. Extremes. Okay. Here A and D are the end terms or extremes. Now, the terms that comes in the middle, which is B and C, they are called means or middle term. Middle terms or means. Here we have B and C. Okay. Now, one more thing to remember is the product of first term and the fourth term, that is end terms, will be equal to the product of second term and third term, that is middle term. A into D will always be equal to B into C. Just take the previous example. We had 2 rectangles. First 2 rectangles. Here 5 centimeter and 3 centimeter. Here 10 centimeter and 6 centimeter. Okay. In this case, A by B. A is equal to 5, B is equal to 3, C is equal to 10 and D is equal to 6. A into D. This ratio is A by B. A by B is equal to C by D. Okay. Here A into D. A into D will be equal to 5 into 6 and B into C. What is B into C? B is 3 and C is 10. Are they equal? What is 5 into 6? 5 into 6 is 30. 3 into 10. 3 into 10 is also 30. They are equal, right? So, we proved that A into D is equal to B into C with our example. That is, product of extremes will always be equal to product of means. Okay. You just need to remember this. Product of extremes will always be equal to the product of means. One more point to remember is, that is, we have A by B and C by D. They are equal. When you are taking different quantities, here, if we are taking distance and time, what happens when time increases? Distance travelled also increases if speed remains a constant. Okay, the units of distance is kilometers and unit of time is hour. We should have same units for the numerator and denominator. If A is in hour, then B also should be in hour. If C is in kilometers, D also should be in kilometers. Only then the ratio will be possible. Got it? These are the basic things you have to remember while studying proportion. First thing, A, B, C, D are called terms. A is the first term, B second term, C third term and D the fourth term. Then what are extremes and means? Extremes are the terms that comes in the ends. Means are the terms which comes in the middle. Okay, then product of extremes will always be equal to the product of means. Here in A, B, C, D, this D is called fourth proportional. Okay, D is called the fourth proportional because it is the fourth term. It is a fourth proportional. You may get questions to find the fourth proportional. In case you don't know the fourth proportional, we will be taking a variable x to find the fourth proportional. Just remember these things. Okay, let us see what continued proportion is. Three non-zero quantities. Let us take A, B and C of the same kind and the same unit. Unit has very importance, okay, are said to be in continued proportion if the ratio of first to second is same as the ratio of second to the third. Here the first we have A, second is B and third is C. According to continued proportion, A by B will be equal to B by C. Okay, A by B is equal to B by C. Here we are taking only three terms. If you have many terms, you can write this as A by B is equal to B by C is equal to C by D is equal to D by E is equal to etc. etc. Okay, now in this A by B is equal to B by C, B is called mean proportional. Okay, mean proportional. And C is called third proportional. Third proportional. We know what fourth proportional is. If you have A by B is equal to C by D, then D is the fourth proportional. Here we are having a continued proportion. That is, here the denominator in the first ratio will be the numerator in the second ratio. Here again, denominator in the second ratio is the numerator in the third ratio. When you take only this part, that is A by B is equal to B by C. B is the mean proportional and C is known as the third proportional. Got it? So this is the idea about continued proportion. Okay, if you have A by B is equal to B by C, then you can write this as cross multiplying. You get A into C is equal to B into B, or B square is equal to AC. We will be getting B square is equal to AC. For solving, we will be using these. Clear? Let us solve an example. First question, find the fourth proportional to 3, 6 and 4.3. Okay. The first term is 3, second term is 6, third term is 4.5 and we need to find the fourth proportional. In that case, we will take fourth proportional as x. The unknown quantity we usually take as x. Let, first question, let the fourth proportional be x. Let the fourth proportional be x. So this can be written as 3 by 6 is equal to 4.5 divided by x, which is 3 is to 6 as 4.5 is to x. Okay, this can be written as 3 by 6 is equal to 4.5 divided by x. Next step, cross multiplying, we get 3 into x is equal to 4.5 into 6. Or x is equal to 3 into taken to the opposite side becomes division. 4.5 into 6 divided by 3. 3 and 6 can be cancelled. 3 2s are 6 into 2. Okay. So 4.5 into 2. What is 4.5 into 2? 9. The fourth proportional is 9. Clear? This is how we can find the fourth proportional. Now the second question. The mean proportional between 6.25 and 0.16. We need to find the mean proportional. Again, take mean proportional as x. Let mean proportional be x. Let mean proportional be x. Now, how can we write this? 6.25 divided by x is equal to x divided by 0.16. Okay. Next step, cross multiplying. 6.25 into 0.16 is equal to x square, or x square is equal to, what is 6.25 into 0.16? 625 into 16. 625 into 16. 6 into 5, 30. 6 2s are 12. 15. 6 into 6, 36. 37. 1 into 5, 5. 2 into 1, 2. 6 into 1, 6. 0. 5 plus 5, 10. 7 plus 1, 8. Plus 2, 10. 3 plus 6, 9. Plus 1, 10. Okay. We got 10,000. Now here, check the points. Here, 2 decimals. Here again, 2 decimals. Therefore, 4 decimals. 1.0000. That is x square is equal to 1 or x is equal to root 1, which is equal to 1. Okay. The mean proportional value x is equal to 1. Now, the third, we need to find the third proportional to 1.2 and 1.8. Let third proportional be x. Now, how can we represent this? We need to find the third proportional. 1.2 divided by the second term, 1.8. And the third term is also 1.8. 1.8 divided by x. Fourth proportional comes here. Okay. Now, cross multiplying. 1.2 into x is equal to 1.8 into 1.8. Or x is equal to 1.8 into 1.8 divided by 1.2. Now, we need to remove decimal. Here, to remove decimal, I can multiply by 10. Here again, I can multiply by 10. In the numerator, I am multiplying by 100. Therefore, denominator also I should multiply by 100. This becomes 1.8 into 10 into 1.8 into 10 divided by 1.2 into 10 into 10, which is equal to 18 into 18 divided by 12 into 10. That is equal to 18 and 12 can be cancelled. 6 2s are 12 and 6 3s are 18. This 2 and 18 can be cancelled. 2 into 9 is 18. So, here we get 9. 9 into 3, 27. 27 divided by 10, 2.7. 2.7 is the third proportional. Clear? Now, you know how to find the fourth proportional, mean proportional and the third proportional. Clear? Example 2. Quantities A, 2, 10 and B are in continued proportion. Find the values of A and B. What was continued proportion? A by B is equal to B by C is equal to C by D is equal to D by E, etc. This is what continued proportion is. Here we have 4 terms. In continued proportion, we can write this as A by 2 is equal to 2 by 10 is equal to 10 by B. To find the values of A and B, we can take them separately. First, this part. A by 2 is equal to 2 by 10. Okay. Now, to find A, we need to cross multiply. A into 10 is equal to 2 into 2. Then what is A? A is equal to 2 into 2 divided by 10. That is equal to 2 into 2, 4 divided by 10 is equal to 0.4. We got the value of A. Now, the second part, this part. 2 by 10 is equal to 10 by B. Again, cross multiplying. 2 into B is equal to 10 into 10. Or B is equal to 10 into 10 divided by 2, cancelling. 2 into 5 is 10. So, here we get 5. 5 into 10, 15. The value of B is equal to 50. Let us check this. The first ratio, that is A by 2. We know the value of A, 0.4 by 2. I am multiplying to remove decimal, multiplying with 10 on numerator and denominator, that is equal to 4 by 20. 4 by 20 is equal to 1 by 5. We got this ratio as 1 by 5. Now, the second, it is 2 by 10. 2 by 10. 2 by 10 we know it is equal to 1 by 5. Now, the third, 10 by B. 10 by B is equal to 10 by, what is the value of B? 50. 50, cancelling the zeros, we get 1 by 5. All the ratios are same. They are in continued proportion. Clear? Example 3. If A plus C is equal to MB and A by B plus A by D is equal to M by C, prove that A, B, C and D are in proportion. When do we say these terms are in proportion? We should get the form A is to B as C is to D, or A by B is equal to C by D. We need to get this form. Here it is given that given A plus C is equal to MB and 1 by B plus 1 by D is equal to M by C. Okay, I will show you two methods. The first method, using this, we are going to take the LCM of the denominators. We have B and D. The LCM is BD. What about numerator? Here we have B. B into D is BD. D into 1, D. Plus D into B is BD. B into 1, B is equal to M by C. Next step, cross multiplication. C into D plus B is equal to MBD. We have MB is equal to A plus C. We can substitute it here. C into D plus B is equal to A plus C into D. Now, removing the brackets and multiplying, we get CD plus CB is equal to AD plus CD. Okay. Here LHS we have CD and on RHS also we have CD. This can be cancelled. Then CB is equal to AD, or we can write this as C by D is equal to A by B. A by B is equal to C by D. We got the form of a proportion, that is A is to B as C is to D. Okay. We proved A is to B is equal to C is to D. Okay. Now, I will show you the second method. Method 2. We need to get the form A by B is equal to C by D. Okay. Which one is comfortable to you? You can use that method. Here, we are taking 1 by B plus 1 by D is equal to M by C. And the second, A plus C is equal to MB. From this, I can write M is equal to A plus C divided by B. Okay, M is equal to A plus C divided by B. Now, substituting this value of M in this equation, that is 1 by B plus 1 by D is equal to A plus C by B. Here in the place of M, we are substituting A plus C by B into 1 by C. M by C, that is A plus C by B into 1 by C. Now, the normal things, that is, we have to arrange this for that, taking LCM. Here it is BD, numerator D plus B. In this side, BC, numerator A plus C. Okay, here we have a B, here we have a B which can be cancelled. D plus B by D is equal to A plus C by C. Next step, cross multiplying, we get C into D plus B is equal to D into A plus C. Removing brackets and multiplying, CD plus CB is equal to DA plus DC. DC and CD are the same, which can be cancelled. We have CB is equal to DA or C by D is equal to A by B. This is the required form. A by B is equal to C by D. Any of these two methods you can use, which is comfortable to you. Okay, clear? Example 4. If A, B, C and D are in proportion, prove that A minus B divided by C minus D is equal to root of 3A square plus 8B square divided by 3C square plus 8D square. Here, we are using a new method which is called K method. K method. Okay. If A, B, C, D are in proportion, we can write this as A by B is equal to C by D. The value of A by B and the value of C by D are equal. We can take this as some K. Okay. The value is equal, right? We can take it as some constant K. Now, A by B is equal to K and C by D is also equal to K. Okay. So, you can write A is equal to K into B, C is equal to K into D. We got A is equal to KB and C is equal to KD. We are going to substitute this value of A and C in LHS and RHS. Okay. First, let's take LHS. LHS we have A minus B divided by C minus D. Okay. Here A is equal to KB, substituting KB minus B divided by C is KD. KD minus D. Now, taking common outside, B is common, B is taken out, remaining K minus 1. K minus 1 divided by D into K minus 1. K minus 1 and K minus 1 can be cancelled. Numerator and denominator, we have K minus 1 which can be cancelled. We have LHS is equal to B by D. Now take RHS. RHS is lengthy. We have root of 3A square plus 8B square divided by 3C square plus 8D square, which is equal to, keep the root as it is, 3A square. In place of A substitute KB and in place of C substitute KD. 3 into KB square plus 8B square divided by 3 into KD whole square plus 8D square, which is equal to root of. This can be written as 3K square B square plus 8B square divided by 3K square D square plus 8D square, which is equal to, B square is common, taking out B square, D square is common in the denominator, taking them out. We get root as it is b square into remaining 3k square plus 8. 3k square plus 8 divided by d square is common, d square into 3k square plus 8. What to do next? Yeah, we have a common term here, 3k square plus 8 in the numerator and denominator. Cancelling, we get root of b square plus d square. What is root of b square plus d square? Removing square and root. This can be written as root of b by d whole square. Root and square get cancelled. We will be getting b by d. That is, RHS is also equal to b by d. LHS is equal to RHS. LHS is equal to RHS. Hence, proved. Got it? This is how we do using the K method. Substituting for A by B K and C by D K, from which A is taken as KB, C is taken as KD. Okay, it is a constant. K represents a constant. Now let us solve more questions from exercise 7B. Here is our first question. Question 1 of exercise 7B. Find the fourth proportional to first question 1.5, 4.5 and 3.5. We need to find the fourth proportional. For that, let us suppose the fourth proportional as x. Let the fourth proportional be x. Let the fourth proportional be x. When we have an unknown quantity, we take them as x. So here this can be written as 1.5 by 4.5 is equal to 3.5 divided by x. Okay. Next step, cross multiplying. 1.5 into x is equal to 3.5 into 4.5. Then x is equal to 3.5 into 4.5 divided by, taking this 1.5 to the opposite side, it becomes division. 1.5. Now we can remove decimals. That is 3.5 into 10, 4.5 into 10 divided by 100. Because here we are in the numerator, we are multiplying with 100. Therefore, in the denominator also we need to multiply with 100. This becomes 3.5 into 10 into 4.5 into 10 divided by 1.5 into 10 into 10. Okay. Whatever you multiply in the numerator, you need to do the same in the denominator. So, 3.5 into 10 becomes 35 into 4.5 into 10 is 45 divided by 1.5 into 10, 15 into 10. That is equal to 15 and 45 can be cancelled. We get 3. 15 into 3 is 45. 35 into 3, you will be getting 105 divided by 10, which is equal to 10.5. Okay, the value of x is 10.5. What is x? X is the fourth proportional. We got the fourth proportional as 10.5. Clear? Now the second question, 3a, 6a square, 2ab square. We need to find the fourth proportional. Again, we will take the fourth proportional as x. Let fourth proportional be x. Be x. This can be written as 3a divided by 6a square is equal to 2ab square divided by x. We need to find x. Cross multiplying, 3a into x is equal to 2ab square into 6a square. That is equal to x equal to 2ab square into 6a square divided by 3a. A can be cancelled. 1a from the numerator and 1a from the denominator can be cancelled. 3 and 6 can be cancelled. 3 into 2 is 6. So, here we get 2. What is remaining? X is equal to 4a square b square. X is equal to 4a square B square is your answer. Got it? Very simple, right? We just need to take the fourth proportional as x, substitute and find the value of x. Okay, let's move on to the next question. Second problem, question number 2 of exercise 7b. Find the third proportional to the first question 2 by 3 and 4. Second, a minus b and a square minus b square. Okay, let's take the first question, that is 2 by 3 and 4. Here we need to find the third proportional, which means we have to take third proportional as x. Let the third proportional be x. Will be x. Okay. Here we have a mixed fraction. We need to first convert it into improper fraction. 2 into 3, 6. 6 plus 2, 8. 8 by 3 and 4. Okay. Now this can be written as 8 by 3 is to 4 as 4 is to x. Okay. To find x. Now this is 8 by 3 divided by 4 is equal to 4 by x. Cross multiplying, we get 8 by 3 into x is equal to 4 into 4. X is equal to 4 into 4, taking the reciprocal and multiplying. That is 3 divided by 8. 4 and 8 can be cancelled. 4 2s are 8. 2 and 4 can be cancelled. 2 2s are 4. So the remaining we have x is equal to 6. X is equal to 6. Okay. Where x is a third proportional. We got the third proportional as 6. Got it? Now the second part. A minus b and a square minus b square. Here again we have to take x as the third proportional. Let third proportional be x. You cannot directly use x. First, this statement is required. Let third proportional be x. Okay. This can be written as a minus b is to a square minus b square as a square minus b square is to x. Next step, a minus b divided by a square minus b square is equal to a square minus b square divided by x. We need to find x. Cross multiplying this, a minus b into x is equal to a square minus b square into a square minus b square. Okay. Therefore, x is equal to a square minus b square can be written as a plus b into a minus b. Algebraic formula, a plus b into a minus b into a square minus b square divided by, here we have an a minus b, taking it to the opposite side becomes division, a minus b. Okay. We are changing this a square minus b square to a plus b into a minus b so that we can cancel this from numerator and denominator. A minus b can be cancelled. Cancelling. Then x is equal to a plus b into a square minus b square, which is our third proportional. There is no other modification to be done. This is your final answer. X is equal to a plus b into a square minus b square. Understood? Now the next question, problem 3, question 3 of exercise 7b. Find the mean proportional between, first one, 6 plus 3 root 3 and 8 minus 4 root 3. Here we have to take the mean proportional as x. Let mean proportional be x. Be x. Now, this can be written as 6 plus 3 root 3 is to x as x is to 8 minus 4 root 3. Here we have x 2 times because this is a mean proportional. The mean proportional is taken as x. That is 6 plus 3 root 3 divided by x is equal to x by 8 minus 4 root 3. Next step, cross multiplying. 6 plus 3 root 3 into 8 minus 4 root 3 is equal to x square. Or x square is equal to 6 plus 3 root 3 into 8 minus 4 root 3. Now removing brackets and multiplying. That is x square is equal to 6 into 8 minus 4 root 3 plus 3 root 3 into 8 minus 4 root 3. Okay. X square is equal to 6 into 8, 48 minus 6 into 4, 24, 24 root 3 plus 3 into 8 is 24, 24 root 3 minus 3 into 4, 12, root 3 into root 3 is 3, 12 into 3, 36 minus 36. That is x square is equal to, here we have minus 24 root 3 and plus 24 root 3 which can be cancelled. Okay, 48 minus 36. X square is equal to 48 minus 36 is 12. X is equal to root 12. Okay, 12 can be written as 4 into 3, right? 4 is a perfect square number. That is, we can take this 4 outside by taking the square root of 4. Square root of 4 is 2. Then this becomes equal to 2 root 3. Okay, the value of x is 2 root 3. Our mean proportional is 2 root 3. Okay, now the second one, a minus b and a cube minus a square b. Here again we are taking the mean proportional as x. Let the mean proportional be x. This can be written as a minus b is to x as x is to a cube minus a square b. That is, a minus b divided by x is equal to x divided by a cube minus a square b. Cross multiplying, a minus b into a cube minus a square b is equal to x square. Okay, that is, x square is equal to a minus b into a cube minus a square b. Here from this a square can be taken out. That is, a minus b into a square into a minus b. From a cube, when you take a square out, remaining you have a. From a square b, when you take a square out, remaining you have b. That is, x square is equal to a square into a minus b into a minus b is a minus b whole square. A minus b whole square. Now to find x, we just need to take the square root. X is equal to root of a square into a minus b whole square, which is equal to square and root can be removed. That is a into a minus b. Okay, x is equal to a into a minus b. That is, mean proportional is equal to a into a minus b. Okay, problem 4. Question 7.1 of exercise 7b. If a, b, c are in continued proportion, show that a square plus b square divided by b into a plus c is equal to b into a plus c divided by b square plus c square. Okay, for a continued proportion, we know that A by B is equal to B by C. This can be written as A into C is equal to B square just by crossing. That is B square is equal to AC. Okay, B square is equal to AC. Here A square plus B square divided by B into A plus C is the LHS, and B into A plus C divided by B square plus C square is the RHS, right hand side. First, let's take the left hand side. LHS is equal to A square plus B square divided by B into A plus C. We have B square is equal to AC. We are going to substitute that here. This becomes equal to A square plus AC divided by B into A plus C. Okay. Now, here A is common. A can be taken out. A into A plus C divided by B into A plus C. A plus C is common in both numerator and denominator. Therefore, it can be cancelled. Remaining, we have A by B, which means LHS is equal to A by B. Okay. Now, take RHS. RHS is B into A plus C divided by B square plus C square. Here again substitute B square is equal to AC equal to B into A plus C divided by AC plus C square. Next step, here in the denominator C is common, C can be taken out. That is B into A plus C divided by C into A plus C. A plus C can be cancelled. Remaining we have B by C. Now LHS is equal to A by B and RHS is equal to B by C. Are they equal? Here we have A by B is equal to B by C. This is a continued proportion. So B by C is equal to A by B. LHS is A by B and now RHS is also equal to A by B. LHS is equal to RHS, which means we have proved this is equal. Okay. Question 7.2. If A, B, C are in continued proportion and A into B minus C is equal to 2B, prove that A minus C is equal to 2 into A plus B divided by A. Here, this is a continued proportion. Therefore, A by B is equal to B by C, from which we can write AC is equal to B square. Okay. Given A into B minus C is equal to 2B. Okay. Removing this brackets and multiplying, we get AB minus AC is equal to 2B. We know AC is equal to B square. Substituting AB minus B square is equal to 2B. Taking common, B is common. Remaining we have A minus B, that is equal to 2B. Cancelling B from both LHS and RHS. We get A minus B is equal to 2. Here in this question, LHS we have A minus C. Okay. What about RHS? RHS is equal to 2 into A plus B divided by A. Okay. We need to make some modifications here. This can be written as 2 is equal to A minus B. Substituting this here, we get A minus B into A plus B divided by A. A minus B into A plus B is A square minus B square. A square minus B square divided by A. We have B square is equal to AC. Substituting, this is equal to A square minus AC divided by A equal to, A is common, taking A out, we get A minus C divided by A. A into A minus C divided by A. Cancelling. From numerator and denominator, we can cancel A. We get A minus C, which is RHS. LHS, we have A minus C. RHS is equal to A minus C. Therefore, LHS is equal to RHS. Hence, proved. Okay. We proved A minus C is equal to 2 into A plus B divided by A. Question 7.3. If A by B is equal to C by D, show that A cube C plus AC cube divided by B cube D plus BD cube is equal to A plus C whole raised to 4 divided by B plus D whole raised to 4. Here we will solve this by using the K method. We have A by B is equal to C by D. This is equal to K. We can take A by B is equal to K and C by D is equal to K. A by B is equal to K means A is equal to BK. C by D is equal to K means C is equal to DK. Okay. Take the LHS. Here in the LHS we have A cube C plus AC cube divided by B cube D plus BD cube. Now, in place of A, we are going to substitute BK, and in place of C, we are going to substitute DK. This becomes A cube BK whole cube into C. C is DK. DK plus AC cube, that is BK into DK whole cube divided by denominator the same, that is B cube D plus BD cube. Okay, this becomes B cube K cube D K plus BK D cube K cube divided by B cube D plus BD cube. This is equal to K cube into K is K raised to 4. K raised to 4 B cube D plus BD cube K raised to 4 divided by B cube D plus BD cube. Here K raised to 4 is common, taking out K raised to 4. Remaining we have B cube D plus BD cube divided by B cube D plus BD cube. From numerator and denominator, this term can be cancelled. B cube D plus BD cube. So, LHS is K raised to 4. LHS is equal to K raised to 4. Now, we can take RHS. We have A is equal to BK and C is equal to DK. RHS is equal to A plus C whole raised to 4 divided by B plus D whole raised to 4. That is equal to A is equal to BK, BK plus C whole raised to 4 divided by, that is equal to A is equal to BK, BK plus C is equal to DK, DK whole raised to 4 divided by B plus D whole raised to 4. Here K is common. K into B plus D whole raised to 4 divided by B plus D raised to 4. That is equal to K raised to 4 into B plus D whole raised to 4 divided by B plus D whole raised to 4. B plus D raised to 4 can be cancelled. Remaining we have K raised to 4. Therefore, RHS is equal to K raised to 4. We got LHS K raised to 4 and RHS K raised to 4. Therefore, LHS is equal to RHS. LHS is equal to RHS. We had to prove A cube C plus AC cube divided by B cube D plus BD cube is equal to A plus C whole raised to 4 divided by b plus d whole raised to 4. Taking LHS and RHS separately and putting A is equal to BK and C is equal to DK, we reached LHS is equal to K raised to 4 and RHS is equal to K raised to 4 and proved. Problem 5, question 10 of exercise 7B. If Q is the mean proportional between P and R, show that PQR into P plus Q plus R whole cube is equal to PQ plus QR plus PR whole cube. Okay, here mean proportional is Q, that is P is to Q as Q is to R. Now this can be written as P by Q is equal to Q by R, which implies Q square is equal to PR. Either we can substitute Q square is equal to PR and solve this, or use the K method. Here LHS we have PQR into P plus Q plus R whole cube. Okay. Now here this P into R is equal to Q square. This can be written as Q square into Q into P plus Q plus R whole cube. Q square into Q is Q cube. Q cube into P plus Q plus R whole cube. That is equal to Q into P plus Q plus R whole cube. Okay. Now removing this brackets and multiplying, we will be getting QP plus Q into Q is Q square plus Q into R, QR whole cube. Now this is somewhat similar to our RHS. Here we have a QR, here again QR. We have a PR, but PR is not found here. But we know Q square is equal to PR. We just need to replace this Q square as PR. We will be getting QP plus PR plus QR whole cube, which is equal to RHS. All other terms are the same. PQ is there, PQ is there. Then QR, QR, PR, PR. Therefore, we got LHS and RHS equal. Problem 6, question 12 of exercise 7B. If y is the mean proportional between x and z, prove that x square minus y square plus z square divided by x raised to minus 2 minus y raised to minus 2 plus z raised to minus 2 is equal to y raised to 4. Here the mean proportional is y. We can write x is to y as y is to z. That is x by y is equal to y by z, which implies y square is equal to xz. Y square is equal to xz. Now let us take the LHS. LHS we have x square minus y square plus z square divided by x raised to minus 2 minus y raised to minus 2 plus z raised to minus 2. We know 1 by x is x raised to minus 1. Therefore, x raised to minus 2 can be written as 1 by x square. We will rewrite this. X square minus y square plus z square is the numerator. Denominator, x raised to minus 2 is 1 by x square minus y raised to minus 2 1 by y square plus z raised to minus 2 1 by z square. 1 by z square, which is equal to, wherever we have y square, we can substitute xz. This becomes x square minus xz plus z square divided by 1 by x square minus 1 by xz plus 1 by z square. Okay, that is equal to x square minus xz plus z square divided by, here we are going to take the LCM of x square, xz and z square. What is the LCM? LCM will be equal to x square, z square. x square z square. Now to get x square z square, we need to multiply x square with z square. Z square into 1 is z square. To get x square z square, xz should be multiplied with xz. That is minus xz plus. To get x square z square should be multiplied with x square plus x square. That is equal to x square minus xz plus z square divided by x square minus xz plus z square. I am just rearranging this, and this part goes to the numerator. That is into x square z square. Okay. We know y square is equal to xz. This is equal to xz whole square, right? We are cancelling this and this because numerator and denominator are equal. We can cancel these two. We have x square z square, that is xz whole square. Xz is equal to y square. Substituting, we get y square whole square. That is equal to y raised to 4. What is y raised to 4? Y raised to 4 is the RHS. Okay. Hence, we proved the given thing. Got it? Problem 7, question 14 of exercise 7b. Find two numbers such that the mean proportional between them is 12 and the third proportional to them is 96. We have to take two numbers such that the mean proportional is 12 and the third proportional is 96. Okay, let us take P and Q as the numbers. Let P and Q are the numbers. First thing, mean proportional between them is 12. How to write mean proportional? P is to 12 as 12 is to Q. This is how we can represent the mean proportional. That is, P by 12 is equal to 12 by Q, or crossing we get PQ is equal to 12 into 12, that is 12 square 144. We got PQ is equal to 144. Take it as equation 1. Now, the second part, third proportional to them is 96. Third proportional, that is P is to Q as Q is to 96. This is where third proportional comes. This can be written as P by Q is equal to Q by 96, or crossing we get 96 into P is equal to Q square. Q square is equal to 96P. This is our second equation. We got two equations in terms of two variables P and Q. Now comparing this, we can solve to get the values of P and Q. From the first equation, equation 1 implies Q is equal to 144 divided by P. We can write Q is equal to 144 divided by P. Here it is multiplication, taking this P to the opposite side becomes division. Now I am substituting this value of Q in the second equation. Here we have Q square, that is 144 divided by P whole square is equal to 96P. Okay. Now this is 144 into 144 divided by P square is equal to 96P, or 144 into 144 is equal to 96P into, taking this P square to the opposite side, we get P square here. Okay, that is 96 P into P square is P cube. P cube is equal to 144 into 144, or P cube is equal to 144 into 144 divided by 96. Okay. 12 into 8 is 96. 12 into 12 is 144. Again, 8 is 4 into 2. 144 is 4 into 36. 2 and 36 can be cancelled. We get 24. Now 24 into 12, that is equal to 216. P cube is equal to 216, from which we can find the value of P. We need to take the cube root of 216. 216 dividing by 2, we get 108. Again dividing by 2, 54, 2, 27, 3, 9, 3, 3, 3, 1. Okay. Taking this, we get the cube root of 216 is 2 into 3. 2 into 3, 6. Therefore, P is equal to 6. Now, we need to find Q. We have Q is equal to 144 divided by P. P is equal to 6. What is 144 divided by 6? That is equal to 24. Okay. The value of P is equal to 6 and the value of Q is equal to 24. Clear? This is how we can find the value of P and Q, which are the two numbers we have chosen. Here we have the last question for today, problem 8, question 16 of exercise 7B. If P is to Q is equal to R is to S, then show that MP plus NQ is to Q is equal to MR plus NS is to S. Here we are given P is to Q is equal to R is to S, which can be written as P by Q is equal to R by S. Okay. Now, what is the LHS? LHS is equal to MP plus NQ is to Q. That is MP plus NQ divided by Q. Okay. Which is equal to MP by Q plus NQ by Q. That is M into P by Q plus N into Q by Q. Q and Q can be cancelled. We'll get N. We have P by Q is equal to R by S. That is equal to M into R by S plus N. Okay. We need to get in this form. For that, here with N, we are multiplying S and dividing S. That is equal to M into R by S plus N into S by S. Okay. Now, here we can take S as the LCM from both these terms. Denominator, we have S. Numerator, MR plus NS, which is equal to MR plus NS is to S, which is the RHS. We got from LHS, RHS as MR plus NS is to S. Clear? That's all for today. In today's class, we have studied about proportion and solved questions from exercise 7B. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.